So these things could have been leaking from the day they were installed. It's almost seems like that's what you're suggesting. Very interesting. Next slide. We'll move on. Thank you so much. We're going to get back to some of the other folks. Let's move it over to Tom Woolley from AquaSuite. Tom, take it away.
Thanks, Chuck. Thanks, Andrew, as well. Really interesting to hear a concrete example of how people have reduced water loss. So as Chuck kindly mentioned at the start, I'm Tom Woolley, Business Development Director at Royal Haskonian DHV. On that title slide is something we're really proud of at the moment. So we actually won Water Technology Company of the Year 2 weeks ago from Global Water Intelligence. It's a kind of reflection of where we're going, and my focus within the company is within machine learning and digital solutions. So it's a real focus of how we're trying to switch from being a pure engineering consultancy into software and digital solutions. And I'm going to talk to you today about a project, or one of the projects we're doing in India, which is improving access to water using machine learning. If you could go to the next slide, please. So what is the challenge? I think one of the presenters earlier from ABB mentioned, might have been Grundfos, apologies, the challenge of improving access to water for rural water schemes in India. So we've been working on a number of projects, one of them which is actually illustrated in the photo on the right-hand side of the screen. The key step in getting towards a 24/7 water supply is enabling as much of that water which is produced to get to the end customer, to the end client as possible, to the consumer. And there's a number of challenges involved in that, partly availability of water. So what is available to abstract, and that's only going to get more difficult as we move towards the effects of climate change and the depletion of the watersheds and so on. There's also a number of other challenges in being able to operate these systems correctly. So they're often manually operated. You often have things like the one you can see on the screen here. That's a really long pipe run above ground. So that makes it particularly prone to all the things we've just heard about from Andrew in terms of leakage and water loss, but also illegal connections. It is a challenge across the world where we work, and it's not just in India. We also see it in the Western countries we work as well. Being able to accurately understand where the water goes is really important, and that's what we're doing at the moment in India, is actually being able to understand the system better so that you can operate it better. We could go to the next slide, please. So this is what we do. So we've been doing artificial intelligence, machine learning for the last nearly 25 years. So everyone talks about it being new and there being lots of hype around AI, machine learning. It's not new. There isn't anything particularly novel about the way people are using AI now. It's just that we're getting to the point that data availability is a lot higher than it used to be. So the key thing for operating a water supply system or a water distribution system better, exactly as all the great stuff we just saw from Andrew in his graphs, you've got to have data. You need to have data. And we're now in the place, both in India and across the world, where there is a great availability of data. So we can take data from a water supply system. And traditionally that might be things like flow rates, pressure readings, service reservoir levels, pump operations, bring all that data into a central location within our AquaSuite platform, and then turn that data into something useful. Generally, data has been used for reporting, so it's been able to tell you when things have gone wrong and give you hints about how you might do things in the future. What we do with AquaSuite is take that data, so we take all the data we just talked about, bring it together with things like local calendar, so when our vacation periods, when our school holidays, when our festivals, use weather data as well, and then make a prediction of, in this case, demand, what you can see in your screen. So we're able to take all that data, use machine learning algorithms that we've developed over the last 20 years, and give a really good prediction of what will happen in the future. And when you've got that prediction, you can then start to look at how can we operate our network better? How can we react to unexpected challenges better? Because we have a really good understanding of what's going to happen. And that's kind of the key thing for AquaSuite, but I think digital solutions in general, you can get away from this point of using data for reporting. you can actually use data to make things work better. And that's kind of where we are with AquaSuite. The image you can see on the right-hand side has two green lines, might not come through very well, but you've got a light green and a dark green line. The dark green is our prediction of the water level for the next, water consumption for the next 72 hours. The light green is the actual data. And hopefully what you can see is that really, really close together. And when you've got that certainty, you can then use it to improve what you're doing. And if we go to the next slide, we can hopefully see some of that. Oh, back one, yeah. So this is one of the consequences of what you can do once you understand what's going to happen. So if you've got a prediction of water demand, if you know accurately how much water is required in each village, in each town, in each district metered area, for example, each supply zone, you can then start to look at the point of, right, this is how much we've got, this is how much we can produce. How do we get that water from our production site to those villages, those elevated service reservoirs, in a fair and equitable manner? And that's the key thing of what we're doing with AquaSuite. We make the predictions for the ESRs, the elevated service reservoirs, and from that we know exactly, within 95, 96%, maybe a little bit more, how much water people need. So then we can look at how do we optimize the supply of water to make sure people get enough water, but also that water is supplied fairly. And we start to derive what pumps should do, what valves should do, what should the production plant be producing. All of these things start to come together with what's available from your abstraction point. So you can start to deliver that water to the village or even the town or the city in the most fair and efficient and effective manner. Because if you've got that understanding of what will happen, you can then start to operate everything that bit more efficiently. And if you can make things more efficient, you can save money, and you can also make sure your water is supplied in a fair manner. One consequence, I think this is an old slide, apologies, but there was an additional bullet point on there, is if you've got that certainty of prediction for flow or for pressure, you can also use that to detect leaks. So if you've got a really good 72-hour prediction of flow, for example, into a district metered area, into a water supply zone, and then suddenly when you're looking at the live data, the data zooms up, then that's a really good indication that water's going where it shouldn't go. And that obviously could be a leak, but it also could be somebody connecting to the pipe when they shouldn't do. If you get that notification, if you're able to identify that change in flow really quickly, then you can get out there and find it and fix it quicker. And ultimately, if you can reduce the time from the start of water loss to the end of water loss, you can reduce the total amount of water lost. And that's a project we're working currently on in the UK, of getting that time from start of a leak to the end of a leak down by 25%. And then you can reduce your water loss by at least 25% as well. If we go to the next slide, we can look at some of the benefits which can be realized from AI in the water supply system. If you've got that prediction of water demand, you can then operate your pumps, your dosing systems, your abstraction from your water source more efficiently. Rather than reacting to local changes, so you're increasing and decreasing your pump speed, you're switching your pumps on and off, you can operate it at a more constant rate, which becomes more efficient. So one of our longest term clients of AquaSuite for drinking water supply has been using AquaSuite for over 15 years, and they're realizing anywhere between 8, 9% and 15% energy reduction just by operating their pumps more efficiently. And we expect chemical consumption to be in a similar band of efficiency. So if you're able to predict water demand, then your dosing of alum or your dosing of chlorine can be that bit more efficient. You can lower water loss. We've had some outstanding results of 20% reduction in water loss just by operating it more efficiently. If you can stop switching pumps on and off, then that's great, because it means you're less likely to create bursts on your pipes. If you can reduce the pressure in the water supply network, then you can reduce the water lost from every leak. I think Andrew's presentation, the ones I've highlighted, you can't always fix every single leak. It would be great if every single water supply network had 0% leakage, and if you did have a problem, you found it and fixed it immediately. That's not always possible. If you can reduce your average system pressure in your water supply network, then you can reduce the amount of water lost from those leaks. And ultimately, we can get to the point, which I think everybody wants, that we can supply clean, safe drinking water to everybody as needed. And that's a real big driver for development, both in India and all around the world. And I think that's me. I'll hand back to Chuck.
Great, thanks, Tom. Tom, got a quick question. You know, I know you're up there in Stafford, and you know, the Aqua Suite basically is borrowing off of the experiences technology from Royal Haskellburg, so of which they're managing 80% of the Dutch, the Netherlands water system. So the example you gave, how much of that work did you have on-site people doing data collection, and how much of that can be done remotely? Because I think that's the most important thing in India. You know, with such a large landmass and a technology like yours, how would you answer that?
Yeah, it's a really good question. So we've had clients, and literally our first client from 24 years ago is still using Aqua Suite right now. So when you've got that long-standing relationship, then it's perhaps not always that clear of what you've done to gather that data. But we are doing a project right now to deploy Aqua Suite OPIR, which is our water supply solution in India. Because of the COVID situation, all of that's been done remotely. So outside of me visiting in 2019, no one from our company. So we're
I don't know if we lost him. Are you still there, Tom? I think we may have lost Tom. Yeah. And so with that, let's go on to the next slide. Tom, thank you so much for that. Tom in his pajamas, remotely managing India. I've got that thought now. Let's move on to our third speaker, the delightful Delph Mack from Xylem. Straight over to you, Delph.
Hi everyone, my name is Delph Mack and I'm from Xylem. So in Xylem, my role is to cover digital solutions. So Xylem Digital Solutions, I'm a regional director based in Singapore. And today my topic is on decision intelligence approach to water. Just quickly give a quick brief about Xylem. It is a water technology company. We have a revenue about 5 billion last year and focusing on various products and services across the water cycle, including pumps, including sensors, water meters, as well as digital solutions. So today I'm just going to cover more about digital solutions. Next slide, please. Yeah, so we use a framework that we call Sense, Predict, Act when we want to design and implement digital solutions. So starting from Sense, basically like what the previous speakers have mentioned, that data is everything. We collect data through various sensors, including flow, pressure, acoustic, water quality sensors, such that we can get data at almost real time, up to data quality of about 256 Hertz for our transient pressure sensors. And by collecting all this big amount of data, we're able to go to the next phase, predict, and we can create and develop this digital twin such that we can understand the real world better. So having this digital twin, which is essentially like a real-time, continuously calibrated hydraulic model, we are able to develop a lot of actionable insights. So applying data analytics, we can go to the next phase act, where we provide insights to operators on how to prioritize how they should operate their networks. For example, where to find these leaks, or which water meters are faulty and need to be repaired, or how to optimize your water treatment plant, wastewater treatment plant, such that you are reducing energy and still maintaining the water effluent conditions that's required by the regulations. So I will go through a few examples on how we use this Sense, Predict, Act framework to provide digital solutions for water utilities. Next slide, please. Yeah, applying a SPA, Sense, Predict, Act, we enable digital solutions across the entire water cycle. So starting from the left, water networks, we can allow functions such as leak and burst detection, monitoring of pressure surge, water hammers that are harmful to the pipelines, monitoring water quality, as well as water balancing. Then as the water comes down to the users, to the buildings or industrial use, we can apply the same approach to enable smart metering applications, metering analytics, to reduce apparent losses, which I will talk more in the example later. And then looking towards the right boxes, so as the water flow through the water pipeline towards wastewater networks, we can still apply the same decision intelligence approach to monitor the wastewater network, to predict overflows, and to control at almost real time how this wastewater can be diverted such that it wouldn't overflow into waterways such as rivers, polluting our water resources. And lastly, as we look at the treatment plants, we can also apply the same approach to optimize treatment plant processes, reducing energy and chemicals usage. In the next slide, I will talk more about an example on how we use the decision intelligence approach on creating a performance-based meter management system. It seems to be a big blur in this slide, but basically I will just walk through to tell you how the SPA approach is applied here. So looking at Sense, basically we collect an abundance of data from consumption, building data, and we understand how this data is affecting the performance of each single meter. So in the predict phase, we analyze this data applying machine learning algorithms to know and understand the pattern, the trend that this meter goes through. And by doing that, in the combination of like weather data, water quality data, as well as like age, we can apply a proactive approach to understand which meters are actually not performing well, in the sense that they are under registering, or they are oversized or undersized, or they are just a lot of anomalies coming through, like having consecutive zeros. Through identifying these underperforming meters, we can allow a prioritized meter management approach, such that we do not replace meters by age, which is not really a good a factor to consider when you want to have your replacement strategy, but you replace only those meters that are underperforming. So that's where the act comes in. You can redesign your strategy on how you replace meters based on each individual's meter's performance and not based on age. Because if you do it based on age, let's say you replace your meters every 8 years, you will end up replacing a lot of meters that are actually functioning well. So in a case study that we did with Clayton Water in US, we actually have helped them to recover several $100,000 of revenue in the first part of the project. And for the subsequent years of working with them, in a total of 5 years so far, we have helped them to recover more revenue along the way. So going to my last example of how we use this SPA approach, the next one, next slide. The next slide, please. Yeah, correct. So this is the last example I'm going to talk about on how we apply the decision intelligence approach. This is on reducing real losses, like some of the previous speakers have covered about real losses. We have a project where we installed 2,000 pressure and acoustic sensors for a major utility in Southeast Asia. Through the data that we collected from these sensors, we are able to collate all of these data into our View platform that applied real-time data analytics to monitor the water network for anomalies, including leaks, bursts, and harmful water hammers. And as such, this utility is able to get actionable insights from our system, and they are able to pinpoint the leaks in a much better way. In total, together with a combination of other initiatives that the utilities have applied to reduce their NRW, this particular utility was able to reduce 50 million liters of water per day, which is a huge achievement. So I'm glad we can contribute to the part of the NRW program. Okay, so that's the end of my presentation.
That's great. Delph, that's wonderful. What a great case study. I've got a question for you though. So you mentioned a reduction of 50 million liters of water. Can you give our attendees a feel for where that's coming from? Is it conservation? Is it pressure? Is it, do you have a sense of really where you're getting the biggest bang for the buck when you do these things?
Yeah, sure. So actually, our system allows them to monitor for leaks and bursts, but they also have like a combination of other technologies that were helping them to drive down this NRW. So they have targeted pipe replacements programs. They also did pressure management to reduce the overall system pressure. On top of that, after they detect leaks and bursts from our monitoring system, they will send their field operators or other technology providers to apply more traditional methods such as acoustic correlators, as well as ground microphones to pinpoint where the leaks exactly is. So we kind of narrow down the area they should look for the leaks and bursts, and then they send another team to pinpoint those leaks. So in combination of all these initiatives, they were able to mainly reduce this water loss through leaks and bursts.
Great, thanks so much. Next slide. That's going to bring us to our final panelist. And Upendra, take it away. And maybe we'll have one time for a group question afterwards.
Okay. Good evening from India. This is Upendra. I represent the CAMSTUB metering solution. And today's data, we come to the topic that we are going to present here, the value of data. Here we are going to present our live case story. Next slide, please. Here we are want to emphasize on what are the challenges faced by the municipalities due to unavailability of the data. So these are the key main 5 points. Non-availability of the water consumption data per connection consumer, difficult to control over water wastage and unauthorized usage, regularized consumption-based water billing system, difficulty in 100% water bill recovery, and the measure is to monitor and manage consumption is a big challenge for effective water management. Next slide, please. So, what a smart metering solution can do for utilities. And here we are presenting the Shirpur Warode Municipal Council 24/7 water supply project with smart AMR ultrasonic water metering solution. The Shirpur, the quick fact is that it is near Dhule district in Maharashtra, North Maharashtra. Population as per 2011 census is 76,905. This city is known for the educational institution. Next slide, please. So key problems and challenges before 2014 for the Shirpur Warode Municipal Council is limited water resource as compared to daily demand, unequitable water supply, 100% connections were without water meters, unaccounted use of water with no proper tracking mechanism for supply and consumption, water bills generated annually on flat rate basis, needed efficient solution to monitor and manage consumption, and main point is gain control of demand and supply management of water. Next slide. Next slide, please. The key result area and benefits after 2018. That first is the major is reduction in consumption. The daily consumption came down from 12 million liters of water per day, reduced to only 8 million liters. The initial project when completed in 2017, it was 10,200 connection, and they assured 24/7 water supply. The key point was supply process efficiency, that is remote reading has reduced the manual efforts to minimum, and the smart alarms for leak, burst, reverse flow, detection, dry alarm, the smart alarms helping them to control over the problems. Then ease of operation and maintenance, because of the high accuracy meter needs no maintenance, and human effort has reduced by approximately 60%. And the next point is saving in time and efforts. The bill preparation time reduced to 4-5 days with the AMR solution from almost 60 days earlier. And as on date, we are successful installation of 13,520 meters are working today. Next slide, please. The findings of the initial assessment of water data mapping. Comparative analysis of water consumption pattern post-meter installation. Difference in water consumption of residential and commercial connection. Consumer segmentation as per high, medium, and low water consumption. And with this all effective data and all importance, that based on the above analysis, the council formed a billing policy based on the telescopic rate. Next slide. It's a comparative analysis chart that pre-meter installation and post-meter installation. The water consumption earlier pre-meter was no estimate for water consumption per capita. Post-meter, exact data on water consumption per capita. Water usage, no control on water consumption, excess water usage. Now, post-meter, citizens have become cautious about their consumption and it has drastically gone down. Daily water supply, initial was intermediate supply 2 times a day before meter. After meter, it is converted to 24/7 water supply. As I mentioned earlier, daily consumption came down from 120 lakhs liters per day to 80 lakhs liters. That reduction is 33.34%. Billing structure, earlier it was a flat rate billing. Now they have consumption-based billing policy. Earlier the bill generation was only annually based. Now they are collecting data monthly and they are issuing the bill quarterly. NRW information, earlier there was no data available. But because of smart meter, now they have leak, burst, dry. These all are alarms, smart alarms of the meters, which help them to take the preventive action. Meter reading, it was earlier manually. Now it's automated meter reading. Earlier meter reading and billing cycle was 50 to 60 days. Now within 5 days. Connection holders, earlier was high number of unauthorized connections resulting in a theft of water. Now it's connection holders with any theft. And the most important, customer service. Earlier there was no connection between the council and the user. Disconnect between the council and consumer, no data was available. Now trust and transparency between the council and consumer due to the accurate meter reading. And the most important is 100% revenue collection since 2018. Next slide. So conclusion is our 3 major aims. You have to measure, monitor, and manage will give the total control. And here the some photographs of site. Next slide, please. These are the actual site photographs where we can see the meter installation, the automated meter reading system, and actual site photographs. Thank you. I hope I'm managing 8 minutes. Thank you.
That's good. Upendra, thanks so much. Go to the next slide. We still have a few minutes left. And so what I'd like to do is, there was a question asked by Deepak, Nick, and the question of Deepak was, and I'm gonna put to each of you, Tom, hopefully you're back online with us, but I'm gonna start with Upendra and I'm gonna go backwards. And the question was, what is a good end goal in India? And if you could just be succinct, what are we trying to go for a goal? You know, how do you measure success? So starting with Upendra, give me a short answer for What's a good end goal?
Sorry, Chuck, could you please repeat the question, please? I didn't get it.
Yes. What is a good end goal in India?
Good end goal.
Objective.
Objective. Looking at the current situation in India, the good objective is to consumption-based billing policy. Accurate consumption-based billing policy is the only answer for unavailability of the or inequitable water supply. If they have the good quality of data and they have the consumption-based billing policy, then they can able to reduce a lot of losses and they can reuse that losses water into the actual mainstream.
Okay,
That's
great. Dilf, how about you? How would you respond to that?
Yeah, thanks for the question. I would say that we have tried to implement a few trials in India, and like any other country, it's not without its own unique set of challenges. And I would say that a good success in India is a successful implementation of a system that can help them to monitor for leaks and bursts. And of course, this comes with overcoming challenges of having to galvanize all the stakeholders within a water utility in India to make that happen. Stakeholder management is definitely quite a great challenge there, as well as to get data from the different stakeholders to allow a digital solution to be implemented successfully.
Okay, great. Tom, are you still online?
I hope so. I hope I'm back. Hope you can hear me, Joe. Sorry about that.
Give us a good goal, short and succinct.
Yeah, so for me, it's simple. I think we need to give as many people, well, everybody water. So safe, clean drinking water. If you give people water, then they'll be able to develop and improve their and their family's lifetime.
And 24/7, I imagine.
Exactly. Everybody should have water whenever they need it.
Whenever they need it. Good answer. And Andrew, our cleanup batter at the end here. What would you? How would you answer that question?
I'd make two observations. That from a company point of view, we want to move from being reactive to proactive. We want to control our own destiny. We want to try and find the problems before they become a problem. And the second part is from the customer point of view. I've heard the comment that when we don't hear from the customers, they're happy. So we'd like not to hear from our customers. If everything's working fine, if they've got water quality and quantity that they require, we don't hear from them as long as they pay their bill at the end of the month. Happy client, you don't hear from them.
That's what I say about my wife too. So if I don't hear from her. So look, with that, I'm going to conclude this session. Thank you so much, all the panelists. Thank you for the great questions. Please note the email addresses that are displayed. I'm sure they'll be made available a little bit later. And again, thank you for your time. And I hope this was benefit for you. And with that, Fred, take it away.
Thanks, Chuck. And spot on. I'm looking at the time. Upendra shows 5 p.m. and on the spot we've closed the session. So that's amazing. And it's great that you moderated it really well. And we're going to hear about electroscan quite a lot in India. So thanks for that. Moving on. For our last panel, we have Paul Hart, who's the director for Metasphere for the Australasia region and has 21 years of water sector experience. For the first 17 years of his career, Paul specialized in flood risk management, working for Royal Haskellingh, interestingly, in the UK, Vietnam, Malaysia, and Australia, before joining Metasphere and spending the last 4 years working in telemetry, remote data collection, principally for major water and gas utilities across Australia, New Zealand, and Southeast Asia. Paul is a member of the Chartered Institute of Water and Environmental Management and has been proud to serve on committees for Australian Water Association, Engineers Australia, and the Scottish Hydrological Society. Paul, over to you.
Fred, thank you very much for those kind words, and good morning, good afternoon, and good evening to everyone, wherever you might be. Just a particular mention to all those that have got up in the middle of the night or stayed up very late at night to either listen or to present. Great effort, thank you for that. And also thank you to Swan for giving me the opportunity to moderate this panel session, which should prove very interesting and informative. We've got 4 great presentations for you with a range of fantastic presenters. Some I've known for many years, some I didn't know before this, and I've enjoyed getting to know. Our presenters are, first up will be Amanda Sequeira, who is CEO and co-founder of Vapor, based in Australia. We'll be co-presenting with Katie Bevan, who is Program Planning Manager for United Utilities in the UK. Then we will have Andreas Weingartner, who is the owner of SCAN, based in Austria. And then we have a presentation from Townsville City Council in Queensland, Australia. And it's been put together by Simon Igloy and Chris Manning. Looking forward to that one. And last but certainly not least is Meena Sankaran, who is the founder and CEO of Kitos, based in the US. So a truly international panel. We also have Stephen Cato, who is Business Development Executive for Taggle Systems, based in Sydney, Australia. So yeah, truly international. We've got some great case studies of where successful projects in the subject of remote monitoring and sensing and innovative business models have been successfully implemented. And we're looking forward to sharing those with you now. So Amanda and Katie, over to you.
Hi everyone. Hi, thanks very much, Paul, appreciate it. Just a quick intro for me. As Paul said, I'm Katie Bevan, I'm the Programme Planning Manager at United Utilities. Paul, if you move on to the next slide for me, please. Thank you. So just to put into context before I move on to the innovation business model, to talk a bit more about United Utilities, where I work. So United Utilities is the UK's largest listed water company, and we serve 7 million customers every day, and we're based in the northwest of England. We've got 72,000 kilometres of sewers, 42,000 kilometres of water mains, and we employ 5,000 employees. So moving on to the innovation side, as that's what I think everyone wants to know about. So at UU, we're very innovation focused. We always have been. We have a specific department of people and a team of individuals that's their sole focus. So every day, day in, day out, it's innovation. It's what they live and breathe. And it's this team that's created what we call the Innovation Lab within United Utilities. So the lab is a specific program. We generally invite small innovative companies to apply for the program. The places are quite sought after, it's very successful. For the companies that are successful in obtaining a place, which is normally about 7 or 8 per iteration, depending on kind of the applicants that we get, we take them through a 12-week activity plan. So they co-locate with us at our head office. We work with the companies to test, develop and demonstrate their products and their services in our live customer environment. So it's a great opportunity for them. Whilst they're there, they also get access to all of our SMEs, our subject matter experts that we have within UU, and obviously also that network opportunity in terms of the senior leaders that we have as well. So as it mentions on the slide, we're in our 3rd iteration, so our 3rd year of the Innovation Lab. It was done for 1 year to see how successful it was and if we wanted to continue, and we obviously have. It's been really successful, it's been great. So we're in our 3rd iteration, and I believe the application stage for that opened this summer. As it mentions on the slide, we've had 1,246 suppliers scouted globally across those 3 years. Just to give you a taster, the location of the companies, there's UK-based companies, there's companies based in Denmark that have been successful, and there's companies that are based in places like Australia, which I'll move on to later. If you can go on to the next slide, please, Paul. So as I mentioned, it's a 12-week program. It's a co-creation program, and we work with a company called Marks, who are some innovation specialists, to kind of complete the program with them and kind of their structure. Of those 1,200 suppliers that I've scouted, we've had 15 live trials that have taken place, and we've got continued relationships with 6 of those from those 1st and 2nd iterations. So if you think, that's probably about half of the successful companies. So it's a really great kind of I guess showcase for how well it works, is that we wanted to continue relationships with half of those companies. So Vapor is one of those companies. So Vapor was successful in obtaining a place in our second iteration, which was last year, alongside about 7 other suppliers. So Vapor, based in Australia, they came and worked at our head office with us. I'm going to hand over to Amanda now on the next slide, please, and she's going to talk you through the learnings from the lab. Thank you.
Thanks, Katie. Good afternoon, everyone. My name is Amanda, and I'm one of the co-founders of Vapor. Vapor is a Sydney-based startup that automates CCTV defect identification and condition assessment directly from CCTV pipe inspection footage. So we do this using deep learning through a cloud platform, and we've actually shown to be outperforming the accuracy and standardization of manual condition assessment to date. Where this kind of comes in handy for water utilities like United Utilities is when you're challenged to kind of sustainably manage the asset backlog, asset renewal backlog that is. So we can apply deep learning technology from the primary source of information, that is the inspection footage that's captured from the internal condition of the pipe, and accurately standardize condition assessment to optimize both CapEx and OpEx works further out. So not only this financial year, but successive financial years. That's kind of where we sit and where the tech is applied. So we started in 2018. We're now operating in not just Australia, which is our kind of home country, but also New Zealand and now the UK, which we're really excited about. Like Katie mentioned, we were part of Lab 2. And what we used, we applied from Australia and went over for the 12 weeks. So we co-located with United Utilities in their Warrington office. And we used that 12-week opportunity to kind of be around the engineers there and really learn from them and the UK water scene. Not only that, to retrain our AI models to fit better with the UK standard. So when we went into the lab, we were just to the Australian standard, but we use that as an opportunity to kind of morph what we'd started in Australia to the UK. And we also worked with UU and their contractors as well to try and identify opportunities to speed up the overall turnaround time that is associated with the capture, the data handling, the data basing of CCTV inspection footage. So really that primary source of information where lots of repair decisions are being made. Next slide, please. So once we finished that, we continued to work with UU, and so this slide is actually about the next project that we did with them. So after the 12-week lab, we then went on to do a further project, kind of like a interim project to continue the work that we've done on the lab. So to further test our models that we had retrained is what we just completed. So completed that 18-week project to not only test the models, but to integrate into the current workflow. And I think that was one of the really interesting takeaways from the whole innovation lab and the business model that United Utilities has is their ability to take something quite innovative and new and try and get that into BAU if there's value. So we're currently scoping the next phase to get that engagement into more of a BAU so that the wider United Utilities business can benefit from this automation. So that planned rollout phase is about to start happening. So not only in the teams that are dealing with planned renewals and planned pipe replacements and pipe inspections, but also those teams that are a little bit more reactive in the approach that they capture and manage CCTV inspection footage. So, and also the newly commissioned pipes that are going in ground. So yeah, there's a planned rollout phase going forward. So that's a little bit about what we've done with United Utilities, but also Vapor as a business. So I'll hand back over to Katie to finish up.
Thank you very much, Amanda. Paul, if you move on to the next slide, please. Thank you. So yeah, just kind of briefly to, I suppose, close down. So the end goal, as it mentioned, of the lab is to form long-term commercial relationships. So whilst the program itself is only kind of 12 weeks, 3 months, our aim is for these supplies to be built into our business as usual, BAU ways of working, if possible, and we think there's benefit there, obviously. As an example, as Amanda mentioned, we've kind of done an extended trial with them of 18 weeks, and we're also now looking at a new phase, and we're working with Vapor to really get to the detail of how we can make that happen, how we can get them into our business as usual offering, whereby we think that there's benefit there, which we do believe that there is, and we're hoping to kind of see the output of that based on its next trial. If you can just move to the next slide. Yeah, and so that's the last slide. So thank you very much for your time. Appreciate it. Thank you.
Katie, Amanda, thank you very much for that. Look, I think this is a fantastic win-win innovative business model. To see a major utility reaching out and creating a space where startups can come in and show their value and actually be taken forward to full commercial relationships is fantastic. So congratulations to both. Time is of the essence, and I've got big shoes to fill. Chuck did such a good job of moderating panel 2 and keeping to time. We're going to move swiftly on to Andreas. Over to you.
Thank you, Paul, for your kind introduction, and hello to everybody. Happy to have you on board of my short presentation. Let me just add one remark. I have stepped back from daily operation of the company, and I'm now active more as a consultant with a current focus on monitoring of industrial effluents and drinking water security. And I also have more time for my most recent baby, the Water Transparency Foundation, which is a non-profit dedicated to transparency and public accessibility of water, firstly established in Mexico. And I do hope to synchronize this initiative at some stage with the wonderful Swan activities and Swan members. Next slide, please. So this is a overview, a quick view on the 5-layer smart water network model of Swan, which is in the middle of that slide here, with the physical layer, sensing and control layer, collection and communication layer, data management and display layer, and data fusion and analysis layer. The letters are too small, so if you're interested into the details, please visit the Swan web pages and check this model out. So my idea was, how can I connect this? How can I translate this model into the real world? So at first you see the sensors. We need sensors for sure. They are our eyes in the water system. Without sensors, we are blind. Please visit our web pages if you want to know more about sensors. The next is merging sensors and terminals into stations. Next will be software to manage these sensors and stations, analyze data, for example, to detect events in real time locally. And our software tool for that purpose is MoniTool, which is today running actually in thousands of instances globally. Next, on the bottom comes the whole field of communication infrastructure. And then we also need software and infrastructure for central data and station management. In our case, we use our Moni Cloud software, for example, in the Ganges monitoring project that I'm going to present shortly. On the right hand, we see analyzing data, translating them into actionable information. It's still a widely unexploited gold mine, I would call it. And I feel that many of my colleagues at this conference, and especially in this panel, are doing a fantastic job in that translation. And finally, all this can be in one hand if you choose services models, such as data as a service. I'm also going to talk about that a little bit later. So next, please. This is an overview of large water quality monitoring networks that I have been involved with more or less over the last 10 years. Thames Water UK, probably the real pioneer. Canal Isabel of Madrid in Spain, another pioneer. Then all those drinking water security projects in the US capitals. More recently, most of the European capitals have started water quality monitoring, partly due to the new European legislation. And also, I consider India a pioneer with the Ganja Basin Monitoring Program and the huge industrial effluents monitoring program, and so on and so on. So in the end, my question is, what do all these have in common? What kind of technology is needed to operate those large monitoring networks? Next, please. So my simple answer is simplicity, simplicity, simplicity of sensors, of software, of operation. Simple is smart. So complex analysis should remain in the lab and not move to the field. Check out the weakest element because this will dictate your service intervals and with that your OPEX. Simple solid state optical sensors will always survive best. Second come electrochemical sensors. Then sensors should be intelligent, autonomous, self-diagnostic, factory calibrated. Avoid reagents, consumables, filters, pumps, and so on. Basically, avoid any moving parts if you can. Install submersed in the tank or in the pipe if you can to avoid pumping. And finally, real-time auto-validation is crucial. Calibration should be a rare exception. Next, please. So let me jump to the first of my short case studies, the Namami Ganga monitoring program, which has basically the great ambition to recover the huge Ganges basin with 500 million population. You can see here the 8 main targets of the program. And one of them, the ones highlighted in yellow, depend very much on water quality monitoring, which are creating sewage treatment capacity, industrial effluent monitoring, and sanitation development of the villages along the river. Next, please. The authority in charge is the Central Pollution Control Board in Delhi, supported by the World Bank. And you can see us here proudly with the Minister for Ganga Rejuvenation, Uma Bharti, at the inauguration time in 2017. We are a joint venture of SKN Messtechnik and Axis Nano, our local partner, with my friend Sanjeev, left to Uma Bharti. We installed together 36 river monitoring stations along 2,500 kilometers, most of them over a period of only 4 months. 34 of them are fixed stations sending 1 data set per hour, while the 2 profiling stations send at least 40 sets per hour, each set consisting of up to 17 parameters. We are also operating a central data management and remote access system, and there is a QA/QC system and protocol in place to continuously validate the data. The contract, it is a 5 years data as a service contract with the India government. That means the equipment remained ours, and we are only selling data to the government. Next, please. This is, I think that was, sorry, can you go back? Yeah, here we are. This is the entry page of our central data management system. The software is called Moni Cloud. From that page, you can access all the stations. You can check what's going on, check the data, the trends. You can compare trends between stations, for example, upstream compared to downstream of an industrial discharge, and many, many more features that I can not explain here in detail. Next, please. During half a year, we installed 36 stations of 3 types. This one is a fixed station, built bridges or dams or other solid infrastructure. They are autonomous, solar powered, and take absolute minimum care. The next one. That profiling stations are mounted on manned boats at places where the Ganges River is actually kilometers wide. The next one. These are floating stations that are typically installed on pontoons and are also completely autonomous. Okay, next one, please. I'm jumping to the next case study, for which I have chosen a typical water utility application. which is actually the combined wastewater and drinking water monitoring program of Canal Isabel II, owned by the Autonomous Community of Madrid. So they are the water authority of the Madrid region in Spain, operating all the water systems from source to discharge, and serve 6.5 million people. You might have heard that Madrid is back to a lockdown situation just now due to infection rates. Not sure if Eva Martinez is also locked down. If yes, I'm so sorry, Eva. Yeah, but actually that makes remote monitoring and control so crucial for utility staff. So they do not have to travel and face risks every day due to traveling. Considering the size of the resources, which is really impressive, mirrored by the data here on the right, they decided quite earlier than others that they wanted to monitor and efficiently control these resources from one central location. And on this map, actually, you can see the green dots here representing 100 wastewater monitoring points, and the blue dots representing the 40 drinking water monitoring points. Next slide, please. And here on this side, on the left, you can see how the big wastewater stations look like. Stations come in all sizes and what parameters they're measuring. In the middle, the same is for the drinking water station, also a very big one, actually. So we installed these 140 systems in 3 phases over about 10 years. Over these years, the network was operated by utility staff. But in 2020, we gladly took over operation, maintenance, and data supply. And with that, now we are responsible for the quality of the data. If you're interested into any technical details, just don't be shy, shoot me a message, and I can also connect you to the relevant people at the utility if you want. Okay, next one, please. So that's my summary, lessons learned. What can I give you to take home from my experience that is specific to water quality data services after 20 years of working with customer projects? So the advantages of data as a service are the initial cost, the CapEx is minimized because the ownership stays with the provider. But I have also seen all kinds of hybrid formats. Service provider professionals are typically well-trained, experienced, and focused on this job because they are doing nothing else 24/7, 365 days. You only pay for plausible data, so you put the risk on the service provider side. And without that, the quality of your water data will be massively better than before. I almost can guarantee that. And in addition, I have a few very practical hints. Choose a very well-reputed provider only with plentiful resources and proven experience track records. Crucial are detailed specification of these services and a good contract. Data qualification and billing should be automated, so you avoid monthly discussion of data and invoices. The biggest risk on the service provider side is being paid. Yes, we do experience some suffering here that I can only recommend to avoid. I have established a QA/QC protocol and use software and central data management to control services and obligatory procedures. And finally, take best use of your precious data. Don't forget tools for automated advanced data analysis, reporting, interpretation, and billing. Only that will facilitate to smoothly turn your online data into actionable information. And I would say the Ganga River Monitoring Tender could be a blueprint for other data as a service projects. So I think that was it from my side. Thank you for your friendly attention. If you have any questions beyond this conference, check me out on LinkedIn or simply send me a Gmail message using my full name with a dot in between, first and second name. Thank you.
Andreas, thank you. I can certainly wholeheartedly endorse your simplicity philosophy. As someone that's responsible for a company that installs a lot of remote equipment, the more remote it is, the simpler and more robust you need it to be. If you have to revisit site for whatever reason, your business case for putting it in the first place is shot. Yeah, I wholeheartedly agree with that. Thank you. Moving swiftly on, we're going to move to Queensland in Australia, and Simon from Townsville City Council.
Excellent. Thank you very much, Paul. Look, as mentioned, I'm Simon from the Townsville City Council in Australia. We're in tropical North Queensland, and look, I'd like to thank the Swan Network for the opportunity to share our journey in that smart water space to date. Also would like to really thank the presenters so far, as very highly knowledgeable experts that have shared some very valuable insights. So very much appreciated. So with that, let's head to the first slide, or the next slide, I should say. Look, just a little bit about Townsville. Very different to some other areas around Europe and Asia. Basically, in terms of population density, we've got 200,000 people over an area that's about 3,500 square kilometres. So quite sparse, a large pipe network that spreads across around about 1,400 kilometres of sewer mains and 2,500 kilometres of water distribution mains. We're in a very dry tropical environment, which means we've got some severe pressures on our water supply. We only get rain probably 3 months of the year, so we've got some extended dry periods for around about 9 months. On top of that, we like to think ourselves of a green and bountiful city, so we have a very high residential water demand, and a lot of that is actually used outdoors on lawns. So it's actually a little bit sad sometimes to see how much water can be used outdoors. We have a long-term average around 500 litres per person per day. So, you know, there's obviously some opportunities there for us to reduce that use through smart technologies and behaviour change, to empower customers to understand how they're using their water and to try and reduce that water use. We've got some pressures as well through natural disasters. You might have seen over in the news, we had 4 years of drought followed by a lovely bit of flooding rain where basically the whole city was underwater. So we have to also build resilience in our water network and our sewer network through that. Next slide, please. Look, we started our digital water metering journey in 2013. We started it with a little trial, very limited trial, about 500 homes to sort of assess and trial the technologies. And through that, we installed more and more of these smart water meters, automated meter reading devices. And we've almost up to about 10% of our population in town now. We're collecting hourly data, and we're feeding that through a meter data management software platform that does some basic data management rules, some analytics, I suppose, in terms of leak detection, automatic notification for customers. So they get SMS messages and use. Obviously, throughout all that time, you think, well, you might have, you know, installed smart meters across the whole town, but the business cases are tricky for smart metering. So throughout the last 7 years, we've been working to basically maximize the value of the existing radio network that we use for our smart water metering. Look, the benefits from smart metering is quite profound in terms of a water conservation perspective. So we've seen that just by visualizing data to customers, we can save up to 10% of water use just by actually behavior change from visualization. So people don't necessarily understand how they're using water. Leak detection is a clear one. So just in September alone, we lost 18 megalitres, 18 million litres in September alone, and that's just with less than 10% of connections metered. We reduce our non-revenue water, so we're obviously detecting water meters that are not functioning properly. We can see illegal connections, and we can also, once areas are grouped into a demand management area, do some reticulation leak detection. The whole data management or the data gathering exercise obviously leads to much improved planning tools. So our data models and everything get fed with real data, a lot less assumption, which then improves the way we can size our pipes and distribute the water through the network. And we'll go to the next slide. I'm trying to do a little bit quick for you here, Paul. I'm trying to sort of catch up on a little bit of time. We'll see how we go. Pressure sensing. So look, like I said before, we had the radio network in town for the last few years. We weren't using a lot of it through smart metering. So sort of went on a little bit of a mission in terms of what else can I use on that radio network. And pressure sensing was a really obvious one. These are quite cheap devices. The pressure sensors you can see in the picture there is attached to the plumbing at the water meter. That water meter in particular has also got a little retrofit smart metering device on there, so we can measure consumption and pressure. This is a really good example for us. So basically, we have a coastal suburb called Palaranda. It's a pretty small coastal suburb. It's about 500 connections in there. But it's got the unfortunate circumstance that it's actually fed by reticulation mains that come off a bulk main, and they're very close to a large butterfly valve that supplies an offshore island through an undersea pipe. Now, the issue we have there is every time that valve opens up to fill the reservoirs on the island, we get extreme pressure drops, leading to a whole lot of complaints, and obviously it's impacting the pipe infrastructure and the lifetime there. Look, a standard engineering solution for us would have been to go ahead, we'll duplicate that pipe, we'll put in a new reticulation main from the suburb across, would have cost us around about $4 million Australian. And look, for basically putting in some of these sensors, we could actually quantify the issue. We'd actually see the real impact of these valve operations that have on the pressure. And what we're investigating now, we've already upgraded the telemetry, and we're working on the actuator on that valve now to actually open the valve slower and to a lesser extent to basically mitigate some of those pressure drops. And we're looking at basically saving almost the whole $4 million just by a few cheap pressure sensors and a little bit of upgrade on the valve infrastructure. So we have plenty of other examples of how pressure sensing has helped us. I'm very limited in time, so if you do want to know some more, send me an email. Not a problem at all. Next slide, please, Paul. Look, level sensing as well. So we've gone into level sensing. We use ultrasonic level sensors, mainly for us in the sewer system. We put them into manholes, so it gives us at the moment 5-minute lead, but I'm going to 15-minute intervals of sewer levels in the system. Basically, look, the 5-minute lead was too much, and I like the battery life to be extended. What you see there, that device is basically the ultrasonic sensor with the transmitter that is transmitting through the stainless, through the steel lid, I suppose, and sends its data through the radio network. It can give us early detections of blockages, so we can actually go out there and fix a blockage before an overflow, which is a lot cheaper and a lot nicer for the residents involved. It also, again, improves the planning. So we actually finally are getting diurnal patterns of our sewage flow through the system, not just at pump stations. So we've always had level sensors at pump stations, but to actually see that through the catchment and see how different sub-catchments actually impacting the sewer pump station is really quite valuable. We've utilized the same thing for river height. So generally we get some very expensive kit to measure river heights. We use it through differential pressures and buffer and bubbler lines. These days, ultrasonics have come a very long way. They're very inexpensive. They're very accurate. They're very maintenance free. So we're moving into that to supplement some of our more robust infrastructure, I should say. And also we're monitoring weir heights for infrastructure for sustainable extraction of water. So we've got a couple of entities in town that are allowed to draw water from our main river and some of our main weirs, and we want to basically monitor the sustainable extraction from that. Look, these sensors, we've been installing them in all sorts of different places, and the next one is actually where we will be installing a couple in groundwater boreholes to monitor the levels and the recharge rates in these boreholes. And I think I've gone over time as well, Paul, so I do apologise. But I think that is my last slide, so we can move on to Mina.
No, that's great. So just a very quick question, actually. You mentioned 18 megalitres lost in September. Yep. Do you have a feel for a dollar value that you would put on that loss of water? And therefore, what's your business case for monitoring and managing it?
Look, it's interesting. So Townsville, the residential tariffs, we actually are based on an allocation system. So it's hard for me to put a distinct dollar figure on the residential consumption. However, if this were billed as commercial usage, that would be $3 per kiloliter. So let me do a very quick calculation because I'm not very good with math.
Sorry, I put you on the spot there, Simon.
Yeah, Darren, thanks for that. So that's roundabout. Is that correct? Anyway. Excuse my slow typing on my calculator.
It's a lot, right? It's a lot.
Yeah, look, it's for a small utility, it's about $55,000 in 1 month, and again, that's less than 10% of connections. So we do see roughly about 1 in 6 homes leaking. No, I should rephrase that, 6% of homes leaking. And interestingly enough, when we installed smart water meters on the schools and public facilities, so anything with a large open space, roughly half of those had substantial leaks. So irrigation leaks are a very big issue here in Townsville for us as well.
All right, brilliant. You can do a lot of monitoring for $55,000, so that's good,
That's
Simon.
very
Thank
true.
you very much. Now, last but certainly not least, Mina, how are you? I think it's 5 a.m. in the morning where you are. I hope you've had a coffee.
Yes, I'm doing great, Paul. No caffeine for me. I've lived caffeine-free all my life, so
Okay, good.
I'm up here around 4 a.m. and excited to participate. Thank you for just the fantastic session so far. And you know, first off, I want to say that I was born and raised in India for the first 17 years of my life. So having personally lived through just, you know, suburbs, village, having experienced all kinds of water, to me, it's very personal and very gratifying to be part of India Innovation Water Week. And, you know, even having a chance to speak a few words here about my passion and, you know, what Kitos is doing in terms of water impact for the customers. So at a very high level, I'm the founder and CEO of a company called Kitos. And after having been in the US and done a lot of work in technology and enterprise data center and large scale architecture for 20 years, it was very essential for me to build and leverage technology for something that had a really strong social impact, just coming from the roots of having seen how both water efficiency and water quality ultimately impact when you look at a lot of the problems. And so I've always looked at them as yin and yang. You can't solve one without really understanding and solving for the other. So we're a company based in California, and we've deployed extensively between US, Canada, India, and Mexico. And I want to share just a couple of quick examples, some glimpses of where customers find value, where are some of our technology innovations, you know, applicable, and how I've sort of looked at it from an outsider's perspective coming into the water sector as an analogous environment compared to other technology, power, energy, grid, and applying those principles so that we're always using the best of what's available. Water is extremely interdisciplinary, and so I think having a non-myopic view to address these challenges are extremely important. Paul, can you go to the next slide, please? Thank you. So, you know, a lot of brilliant speakers have spoken about this philosophy of not looking at siloed. And so fundamentally, the way Kitos solution has been built is a vertically integrated stack. So you've got a system, 2 different types of sensor nodes, one addressing water efficiency, one addressing water quality, both in real time for data management. And you have the entire solution from sensing, from collection, so the communications infrastructure, as well as the services and the platform layer, so that as a customer, ultimately, you're focused on that data. How is that data meaningful to you? And how are we, as a technology provider, enabling you with actionable insights to make your day-to-day operations better? Not trying to make you a technologist or ramp up on new technology every single day, which is just not feasible. So the model is very similar to some of the folks that have discussed here. It's an end-to-end solution offered to customers purely as a data as a service. So there is no CapEx, there is no sort of, you know, you have a lot more predictive expenses in terms of a very flat price as a service model. And I think the whole approach of doing infrastructure as a service, the way we call it, you're really looking to the value of what your water efficiency and leak detection is doing, or what your water quality and safety consumption and effluent discharge is occurring in real time. So Paul, on to the next slide, please. So here's a quick example of sort of smart metering, but you can think of the line.
Mina,
Yeah.
you're back. Sorry, we lost you for a few seconds.
Sorry. So from a Keto smart monitoring standpoint, this is a water efficiency device. And so essentially this sensor node is powered by the flow of water, which is something we've patented. So you have the device in line, and so you're not worried about a plug-in power, you're not worried about Wi-Fi. We communicate through LoRa. And essentially, these can be 100% submerged in water. And because of some of the features we've built and with regards to power management, you now have essentially real-time flow, pressure, and leak detection happening in the distribution grid, and basically a shut-off mechanism so that when you're deciding if you want to shut off a leak, you actually have the option through a valve mechanism to shut the leak off. And these are 100% submerged, and also they can be around 3 to 6 feet under the ground. That's as far as we go from, you know, just the communication range. This was very instrumental for utilities that are deploying for smart metering, because today they had either just a flow meter that was typically available to them, or they were basically driving around and doing analog-based metering in terms of just a person collecting that data. But by allowing this amount of data collection from pressure, flow, variance, and leak detection, we were able to build a very smart distributed grid and then apply forecasting and predictions with machine learning to see what are the patterns, how is the consumer behaving in 90 days, and really kind of using more actionable intel. Next slide, please, Paul. So jumping into kind of, I know I'm context switching here, but jumping into more of the quality aspects of it. You know, somebody asked in the question, how do I really understand digital monitoring from a water quality perspective? There's a lot of instrumentation, online analyzers that are out there for, you know, pH and conductivity and ORP and TDS. But what we've realized, one of the biggest differentiators or really understanding for some of our customers, they were struggling with manganese, they were struggling with arsenic and copper and cadmium and chromium. Northeast India is really struggling with arsenic. So whether it's groundwater monitoring, surface water monitoring, industrial effluent monitoring, you see a few combinations there, that system basically gets deployed, and it's a fixed base system, it's a fixed point system. But once you're installed, you essentially are getting data all the way down from a sensitivity to 1 ppb, 2 ppb level of data. And I would say we are about plus or minus 10% in terms of precision of what you would collect from a NELAC or a local certified lab. We're fairly adherent to a lot of the local standards, we're EPA compliant. So this has been something that has been game changing for us and several customers who have been struggling and spending just a lot of labor, spending someone 2 hours to go grab a sample, prep a sample. So a big advocate from a standpoint of remote water quality monitoring in a way that it's fully autonomous. It's affordable, it's accurate in terms of comparable to lab data for heavy metals in organics. We work a lot with agriculture too, besides utilities and industrial. So it makes a big difference in crop yield and ultimately what you're going to do with a data room in terms of building a network operations center. So my last slide. Go ahead, Paul. Something that is very near and dear to me is also one of the early projects we started doing in Andhra Pradesh as part of Smart Village under the previous government. And we really hope to continue it. This was done across RO plants, local villages, several different hospitals. We did it across 25 villages, mainly because these areas were severely affected by drought. And they were getting water once every 4 days. And we put in a mechanism and working with local partners, local sarpanch, to bring in at least water for a couple hours every single day. A huge gratifying moment, and also something that we hope that we continue doing not just for urban locations and cities, but also for our villages. And I believe villages need to be more smarter than even cities, especially in a country like India. So with that, I'm open to any kinds of questions that you might have. Please reach me offline and I'd be happy to help. Thank you, Paul.
Mina, thank you. Some really fantastic work going on there that's making a difference to people's lives. So congratulations. Look, everyone, I hope you enjoyed those 4 presentations. I think there's some real practical examples there of how you can understand your systems, your networks, and manage them more proactively through knowledge. On that note, Fred, over to you.
Thanks, Paul. Yeah, just a few concluding thoughts and remarks. So it's great that Eva started off on value creation, right at the beginning, and talking about on the security. What is security on quantity versus quality? The smart water ecosystem that Aqualia is setting up through pilots and the success that they're having. Especially the exciting thing is the circular economy really coming to the fore. Together with sustainability and that side. Then we moved on to panel 1, where we had Anglian Water. They're talking about digital enablement. Then the asset group strategies, that was quite interesting to see. And of course, one of the things that we've continuously seen, monitor, model, automate is what Anglian calls it, and the value they see there. Pierre from ABB, talking about some of the exciting case studies, right from Vietnam to Sweden, and how technology is playing a role of utilities addressing some challenges and improving efficiencies and tangibly benefiting from it, both in terms of economic aspects as well as the resource part of it. We had Martin from Grundfos, how the SDG 6 is really taking a focus for a technology company, and how the thinking, especially for technology companies and pump companies like Grundfos, to see how they can look at processes and how they can influence sustainability in a smart way with a process approach. And we had Ken from Jacobs, also the chairman of Swan, and the exciting role of an engineering consulting firm right from the architecture. How do you look at it as from a strategy point of view, and making sure you make the right decisions as you go through. Then we had Andrew Donnelly, and of course this was the session on 24/7, which is even more important for a market like India, and moderated by Chuck. And Andrew was, it was very interesting of the second wave, how EPAL has kind of overcome the second wave there on leakage with some really innovative strategies there. Aquaseat, Tom Woolley there, and how AI and machine learning is addressing the supply and demand management with the case study there in India, which was very interesting. And one of the points which Tom also mentioned in the Q&A session, the end goal is to ensure we have the basic necessity of water to be provided 24/7, and SMART has a role to play there, quite an important role there. Then we had Xylem looking at talking about sense, predict, and act, and the integrated approach that they bring and the tangible benefits that they're providing in some of the key case studies, and also Calmstrup on the actual case study in India. And one of the exciting things there, which I noticed, citizens become more cautious on water consumption, and that reduced consumption by 33%. This is a very important role in India. The demand side management is going to play a key role in how we're going to provide 24/7. And the last concluding session, moderated by Paul, we looked at the exciting innovation lab from United Utilities, how utilities can really partner with some of these startups and provide them an opportunity for pilots, and how successes such as Vapor can really benefit. Scan the data as a service, a business model. Andreas has pioneered this and really highlighted with projects like Namami Gange, really case studies in India. And he himself mentions that where India is a pioneer with these kind of business models, and how it can become a kind of a flagship for how smart water can be deployed and benefit the world as well. And great to see Townsville as well talking about metering and how they're going to be, the benefits that they're seeing both in terms of the residential consumption, where 10% reduction, but also leakage, addressing that point. And, Meena quite wrapped it up with Ketos and looking at platform as a service, how smart solutions can be provided as a platform. And that's really exciting to see. So just thanks to the partners, the speakers, of course, the keynote by Eva, and for the moderators to work with the various panel speakers to put together these really exciting and insightful presentations. The Swan Forum and the Smart Water Waste World have been working on this, and it's worth highlighting the Smart Water India Alliance now is pretty much there. So I would encourage all of you, to really look at it and join the Smart Water India Alliance. And just thanks to the audience, we had close to 1,000 registrants. I'm sure people who and more than 500 people who are online. And it's great that I hope all of you all have benefited from the session. And I'll just hand it over now to Kailash. Kailash?
Thanks, Fred. Thanks for providing us with such a wonderful session. I would again like to highlight that the Swan India Alliance is open in India. The link to the same was shared by Fred earlier and was also shared by Amir in the chat box soon. So in case anybody wants any more details about the Swan India Alliance, do write back to us. I would like to take this opportunity to thank the Swan team for giving us a wonderful session, all the speakers and the moderators for the panel sessions. With this, I bring the day 2 to an end. We will be sharing more details with everybody about the Swan India Alliance through a separate mail. So thank you all, and please do join us for day 3 tomorrow at 4:30 p.m. where we have some very interesting case studies about digital implementations from across the globe. And we will be sharing these live implementations tomorrow. So thank you. With that, I bring day 2 to a close. Thank you all.